How are you, everybody who is watching this lecture or this session or this video? My name is Olenjolai from beautiful, fantastic country, United Republic of Tanzania, or in simple, we call it Tanzania. It is eastern of African continents in case of the map. I'm very happy to be with you as either a national student, a national advanced students, or international advanced students, or you're a parent, or you're a guardian, or you're a chemist, or you're a scientist, or you're a worker, or you're a teacher. I would like to welcome you into our fantastic online platform that's called Tanzania Online Advanced Secondary School, in square bracket OLENJOLAIM. Okay? And then simultaneously to welcome you into our official YouTube channel that's called Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. I'm very happy to be with you today, and I would like just to remind you the visions of this online school. Okay, in Tanzania Online Advanced Secondary Schools, God has given us a clear vision start like this one. Okay, I would like to prepare or incubate some group of students, means that a special group of students who are serious, who have vision in science and in mathematics, who will be ready to take the classroom instructions in advanced chemistry, advanced physics, and advanced mathematics, basic applied mathematics, to combine with the knowledge of the Word of God from the Bible in order to solve real-life problems from our communities, right? So that's the vision that we have in our mind. Just we want to train students to change the way of thinking, to teach them how to think differently, so they can take the classroom instructions that they'll be learning in the class, combining with the knowledge of the Word of God that also I'm going to teach them, or I'm going to teach you, right, in order to solve real-life problems. So once that you touch any book of chemistry, advanced chemistry, you have to think and you have to remember that I'm seeking for the knowledge that required to solve a particular problem in my community. Our main objective here is not to have students to pass the year final exams. Our main objective is to have students, when they are still in advanced level or after they graduate advanced level, to take the knowledge they learned in the classroom, including that my classes, to combine the knowledge of the Word of God in order to solve real-life problems. So our main objective is to have students and even graduate advanced students to solve real-life problems, at least one. It might be a simple problem, it might be intermediate problems, it might be a complex problems, it might be kind of multi-purpose or multi-problems with more than one problem. But our intentions, we want to see graduate students in advanced level solve real-life problems, not problems on a piece of paper. So actually that we'll be teaching you according to the syllabus of United Republic of Tanzania. We'll be teaching the contents as how you learn in the classroom, because that in this program, remember that we are recording the live classes by using the high definitions multimedia equipments, and then that we spread this message into the entire nations of Tanzania by using the internet, and even outside of the borders, of Tanzania. So that's the main objective that we'll be doing. So we'll be training this, but later on, we are building the foundations, means that the fundamental concepts is covered in the classroom. But also you have to expect that in these platforms, I will also teach you the spiritual knowledge of Word of God, so that regardless of your dominations, regardless of your religions, the Word of God is for everybody who want to believe it and test it, whether does it work or it doesn't work. Wow. So that's the visions, and we have some specific objectives to have students to pass the year continuing assessments, to have students also to pass the year advanced certificate secondary education, first year paper 1, paper 2, paper 3. That is our main objective in this. That's one of our specific objectives. But also our specific objective, we want to see our students they receive their academic transcript after they graduate the Form 6 exam. The third specific objective also, we like to see that our students, they graduate successful and they can join in any course in any institutions and with all the minimum requirements. So those are some of the specific objectives we have. So main specific objective that will be achieving them. So what I'm telling you, I would like just to tell you in advance that remember, Olenjolai does not know everything concerning about advanced chemistry or concerning about advanced physics or advanced mathematics or basic mathematics. I just know small portions, but I'm ready to teach others what I know. And I didn't know because I'm very intelligent than possibly yours and somebody else. No, because of the grace of God that has been working in me. And I'm solving real life. This is my problem. So I'm solving a problem, a national problem, right? You know that to cover and master the stuff in advanced chemistry or in advanced physics, especially, it's a challenging moment. But against advanced educations in the Republic of Tanzania is centralized in the business city called Dar es Salaam. So that once you are in any other 31 regions of Tanzania, you have to travel or you have to do the efforts in order to get the knowledge of advanced educations at Dar es Salaam. So ourselves, we want to go beyond of what has been provided in Dar es Salaam, and also we don't want you to come to Dar es Salaam. We just teach you and take the contents which are very worth, which are actual that are simplified, which you have been taught in a simple language, very interesting, accurately, properly, according to the syllabus of United Republic of Tanzania, and then we send them into entire nation of Tanzania. What you just need electronic device and an internet, right? So in our official YouTube channel, we have so many videos right now, more than 100 videos, okay? And we upload more than 500. That's why we are insisting you to update, to subscribe on our YouTube channel, because every day we'll be adding a video in our YouTube channel. Later on, we'll have some other platforms and we'll let you know. So we have 3 departments in this on advanced online advanced Tanzania online advanced secondary school. And one of the departments is called advanced chemistry. We have some 3 subjects there that we have. Okay, 2. Okay, we have advanced chemistry for the Form 5, and we have advanced chemistry for the Form 6. So the class for these contents, these are the contents for the pre-Form 5, okay, Form 5, pre-Form 5, Form 6, okay, pre-Form 5, Form 6E, etc. And Form 6E, college students and the chemists and everybody who has visions in chemistry. So the main topic is general chemistry, okay? And this contains for the Form 5, or we call it class. So Form 5 or Form 6, right? Or in some of the countries, we call it class 13. So for us, this is equivalent to class 13 and class 14, okay? And class 14. Okay, so the topic is called the atomic structure, and the subtopic is called the session 04C, types of spectra in chemistry. And before I begin these sessions, I would like just to tell you that when I was preparing this program, I taught the mass spectrometer, 3 lectures of mass spectrometer, which I broke them into A and B. And then I jumped into Bohr's postulates or Bohr's atomic theory, right? And then I continued to the end of atomic structure. So I jumped the hydrogen spectrum, I jumped the spectral lines, I jumped the quantum theory, I jumped the Rutherford atomic structure, Dalton's atomic structure, so that I just left, unfortunately, only 2 lectures, lecture 4 and lecture 5. So that's why that I'll be on hydrogen spectrums, these types of spectra, hydrogen spectrum, I'll be calling this lecture 4C, lecture 4D, lecture 4E. So you have to watch them sequentially, right? And then I will have also lecture 5A, 5B, C, D, until we cover the remaining contents. I believe you have understood. In case you have any question, we like questions. We are waiting so many types of questions, so many questions in the comment section. So let us start the business. So today I want to teach about types of spectra in chemistry. Say spectra. Say spectra. Okay? So I would like to teach you quickly, and I won't go into too much detail because the syllabus of United Republic of Tanzania, you make sure that you should have this book It's called that the Chemistry Syllabus for Advanced Secondary Education from 5 to Form 60 by Tanzania Institute of Education. If you're Tanzania, you should have this book. In case you don't have, just read the descriptions. You'll see how much does it cost you and what the shipping cost is, so you can ship in any regions of the Republic of Tanzania. So then we say that introduction of spectrum. Okay, introduction. So we say that introduction, and this is the fundamental question. Okay, first question: what is the meaning? What is the meaning? What is the meaning of what? What the meaning of what? What is the meaning of spectrum? We have the word spectrum. What the meaning of the word spectrum? First of all, the word spectrum is come from spectrum. Okay, it's a synonyms of the word spectrum, right? So he said that some of the reference define the word spectrum in this way, that spectrum is the characteristics. So this is the characteristics. This is the characteristics wavelengths. The characteristics wavelengths. The characteristics wavelengths of electromagnetic radiation. Of electromagnetic radiation that is emitted or absorbed by an object or substance or atom or molecule. That are the meanings of spectrum. So spectrum is a characteristics. So spectrum is a characteristics wavelengths of what? Of electromagnetic radiation that is emitted or absorbed by an object or an atom or molecule. So remember that atom or molecule, we are speaking about chemical substance and the means of spectrum. So spectrum is the synonyms of what is spectrum. So we say that is electromagnetic wavelengths of electromagnetic radiations that is emitted or absorbed by an object. So it means that is the spectra we have in chemistry. They can be absorbed by an atom or they can be emitted by an atom. And from this definition now, we deduce two types of spectra, which we call them emission spectra and the absorption spectra. Okay? Emission spectra and absorption spectra. So from this definition, we say that these characteristic wavelengths of electromagnetic radiations can be emitted by an atom or a molecule or a substance, or it can be absorbed by an atom or molecule or a substance. Okay? So we have the types of get prepared to enjoy the beauty of advanced chemistry. Types of spectra. Types of spectra. Okay? So I say that in chemistry, there are two types. There are two types of spectra that are, the first one, we call it emission spectra. Emission spectrum, are the first one. And the second one, we call it absorption spectra. Absorption spectra. Say absorption spectra. Okay, absorption spectra. So I want to insist or I won't go into too much details on this stuff. So we have emission spectra and absorption spectra. So you have those two types. So let us discuss each type of spectra and see how many types of each spectra we have. So then now we go, let us begin with number one, which is called the emission. Say emission. So emission is come from the word emit. Okay, so it's double S, not double L. So this is called the emission spectrum. Emission spectrum. Okay, emission spectrum. So we have this, the second fundamental question. What is emission spectrum? What do you understand when you hear as text the word emission spectrum? What do you understand? Okay? So you say emission spectra, we say that these are in the type of spectrum. This is the type of spectra. Types of spectra obtained, okay, obtained from the substance. So we get this from either substance or from atom or from molecule, right? Okay, molecule by excitation, okay? Excitation of electron. By excitation of electrons, okay? Which cause this substance, okay? Which cause them to radiate, which cause this substances or atoms or molecules, right? Molecules to emit radiation. Radiations of particular wavelengths. Radiation of particular wavelengths. So this is the simplest definitions of emission spectra. So in the type of spectra obtained from what? From the substance or from the atom by excitation of electrons. Say excitation of electrons. You have to understand this phenomenon of excitation of electrons because we're going to discuss it in hydrogen spectrums in different ways. So it means that we'll be explaining and I'll be teaching you and repeating several times about excitation of electrons. So you have to start, bear it in your mind, write it in your mind, say excitations of electrons. So excitations is very important terminology in general chemistry, especially atomic structure. So which cause what? Which cause this substance or atoms or molecules to emit radiations of particular wavelengths. So what does it mean? It means that suppose here we have an atom, right? We have an atom, right? Or we have a substance, for instance. Then it depends. We can have the heat, can have maybe heat, maybe you can have heat, because you have two ways, heat or electric energy. So this is heat, a source of energy. And then we find that we have an electrons here. This is ground state of an atom, for instance. We don't know what does it mean. And then we have the infinity regions here. So if this electrons absorb enough amount of energy, it will jump. It will jump to the possibly the higher energy level, right? And then when it will be coming back to the ground state, it emits what? It emits what? Radiation. So this emits what? Radiations of particular wavelengths. So that the process or the process of emitting these electrons. We say that examples of emission spectrum. Okay, examples of emission spectra are this. The first example, we can have emission spectra by heating a substance at a higher temperature. By heating, okay, we say that emission spectra from heating of the substance. Okay, by heating a substance. Or by heating an atom. Okay, so what does this, or how is this process taken? We said that when an atom is heated, okay, is heated to a certain temperature, then we say that the electrons, because an atom consists of protons, neutrons, and the electrons. So when we heat atoms or substance or molecules, what happens? So we find that the electrons, which always we find them in the valence shell, which take part in the chemical formations of the chemical compounds or chemical reaction. So that when an atom is heated to a certain temperature, we say that then its electrons, we say that absorb. So electrons absorb a sufficient amount of what? Sufficient amount of energy. Sufficient amount of heat energy, okay, that excite an electrons or valence electrons or an electrons from what? From ground state to the higher state. I will teach you in hydrogen spectrums what it is of ground state and higher state. Okay? So that's the process. So it means that when we want to produce emission spectra, by heating, then we say that we have to heat an atom, okay, to a certain temperature, to a certain amount of the temperature, and the electrons of this atom absorb sufficient amount of energy that excite them, or that excite these electrons, okay, excite an electron from the ground state to the higher state. So we say that when these electrons return, so say when this electron, I will explain this, I will show this grammatically when I'll be teaching you the hydrogen spectrum. So I say when the electrons return from higher state to ground state, then it emits radiation of particular wavelengths. So simply we say that suppose that this is an atom, right? So this is ground state and this is higher state. So when we heat this atom, there isn't any particular source of heat. So this is heat. So an electron which was in ground state, possibly here near the nucleus, will be excited into the higher state here, right? So this we call the excitation. So excitation is from the ground state to the higher state or higher energy level. And hence, when this source of heat is removed, then we have our substance now, but the electrons is in higher state. So because the source of heat has been removed, the electrons will return to the ground state. So at this state, it will be emitting radiations. So possible that you'll find emitting radiations like this. So that's types of emission. We call it emission spectrum. In case you have any question of this video, you have to ask it in the comment section. So after teaching you, so that's one of the methods. The second one, which I have to leave as homework for you to go through, is electrical stimulations of the substance. The second is electrical stimulation. Electrical stimulation. Electrical stimulation of a substance. So this is how. So this is homework. Homework for explain how this process is taken. Okay? So that's your business. Then let me teach about types of spectrum. Types of emission spectrum. Types of emission spectrum. We are learning, I'm teaching you about emission spectrum. I don't know everything about emission spectrum, it's not a small question, but I'm going to teach you what I know. So types of emission spectrum, right? So there are three types. There are three types of emission spectrum. Emission spectrum. These are the first one, we'll call it so this is 1.1. The first one we call it continuous spectrum. Say continuous spectrum. Continuous spectrum. The second one we call it band spectrum. Say band spectrum. So when also we be learning about electromagnetic radiation, so electromagnetic waves, we will also learn about this in terms of spectrum. Then the set is called the line spectrum. Line spectrum. So these are the three types of These are the three types of spectrum, of emission spectrum. We have two types of spectrum, but we have three types of emission spectrum. So let me explain in brief what does it mean about continuous spectrum and what does it mean about band spectrum, line spectrum. Means this is called the continuous emission spectrum, band emission spectrum, line emission spectrum. Right? You enjoyed the video for advanced chemistry? Tell me in the comment section. So let us begin with 1.1. And this is continuous spectrum. We'll be discussing in brief because the syllabus does not insist us to teach you so many things about this spectrum. Have just to build a foundation for you. The fundamental question. Fundamental questions to say that what is continuous spectrum? What is continuous spectrum? What is continuous spectrum? Ask your neighbor, ask yourself, what is continuous spectrum? Continuous spectrum, this is still spectrums of wavelengths. but we said a continuous spectrum is the arrangement of all possible radiation radiation of all frequencies over a wide range of frequencies. So we say that this is the arrangement of all possible radiation of all frequencies over a wide range of frequencies. That's the meaning of continuous spectra. So continuous spectra is the arrangements of all possible radiations of all frequencies over a wide range of frequencies. So the difference between band spectra and continuous spectra is continuous spectra occupy a wide range of frequencies. Okay? So because of occupy a wide range of frequencies, that's why we call it continuous spectra. So we say that this continuous spectra can be obtained from the sun. Or any other glowing body. Or any other glowing body. A common example of continuous spectra is so we have a real life example of continuous spectra. Example of a common example of continuous spectra that I'm teaching you. Continuous spectra is rainbow. So that is the common example of continuous spectrum. So a rainbow, you find that it's occupying a wide range. So occupying the wide range. So wide range again. There are so many. There are some colors there. So this is what we call the rainbow. Example for spectra, example of continuous spectra we say that from 400 nanometer to 700 nanometer. So this is the spectra of 40 of white light. So you can check the shape of continuous spectra, okay? Because I told you that I'm going to explain them in brief. The next spectra, we call it line spectra. So let us learn for line emission spectra. So this is line emission spectrum. So then we have a question. So what is line spectrum? What is line spectrum? What's a line? What is line spectrum? So we say that it is the type of spectrum, the type of emission spectrum that consisting of separate lines. Consists of separate lines with very little overlap. With very little or no gap or no grouping at all. So this is the depth of spectra that consists of separated line with very little or no grouping at all. So we say that this line spectrum can be defined, its figure the way it is. We have so many explanations about it. The line spectrum is emitted when element is in glacial state is excited, for example, in an electric district 2. Okay, so that's all about the line emission spectrum. It's a type of spectrum that consists of separate line with very little or no grouping at all. So very little or no grouping at all. There's no groups of 40 of line spectrum. Okay, so it means that we found the figure. The setting is, we call it the bandy emission spectrum. So bandy emission spectrum. So bandy emission spectrum. have a fundamental question. What is band emission spectrum? What is band emission spectrum? Okay, well, I have one of the definitions here. These are the spectrum consist of well-defined number of groups of closely packed lines of a well defined So these are the spectra of a well-defined number of groups These are the spectra of a well-defined number of groups of closely packed lines. Define the number of groups of closely packed lines. About to finish this session, so just be patient with me. In a short time I'll finish and give the homework for you, so you can keep on detailed study of the spectral lines. This is just a fundamental. Packed lines. Other means supporting band emission spectrum. If you sketch it or if I draw it, so this is band spectrum. So this is the band spectrum. So you see that these lines representing the band spectrums. So these lines are close to each other depending on where the spectrum is. 10. So that is band spectra. So when we say about band spectra are usually emitted by molecules, hence the term molecular spectra for the band spectra. How do we produce the band spectra? Band spectra, we say that are usual the band spectra are usually emitted by molecule, hence the term molecular spectra for band spectra. Emitted by molecules, hence the term molecular spectra. Molecular spectra. So the other names of band spectra is what in molecular spectra. You can go different books, read in detail what does it mean, but I have just to build a foundation. So that's all about the emission spectra. So now let me take you to the second types, which is not known, or spectra, which is 1 by 2, we call it absorption. Absorption spectra. Absorption spectra. Say absorption spectra. So absorption is kind of the vice versa of emission. Emission, you are giving out. Absorption, you are taking in. Just like exosemic and endosemic. So absorption spectra is just like its name itself, that means absorption. So we said absorption spectra, we say that by definition is the type of spectra, that is formed when atoms of different elements have take atoms of different elements atoms of 40 formed when atoms of different elements are made to absorb radiation. So he said absorption structure is a type of structure that is formed when atoms of different elements are made to absorb radiation. So when those we call them atoms of different elements are used, then we see that this kind of fluctuations in difference. Excuse me. Okay. And the definitions of 40 of absorption structure. So then now we have a question that defines absorption structure. And the question said that what is the difference? And the difference between absorption structure, between emission and the absorption structure. Okay. So let me answer this question. Say that the emission structure the main difference in this one, the way of generating. Emission structure. So when you write in the lowercase, this is the difference. One of the differences we say emission structure is obtained or can be obtained when electrons so emission structure can be obtained when electrons are gained sufficient amount of energy Okay, gain sufficient amount of energy to be excited to the higher level. And when it returns, it emits radiation. That is emission spectrum. While absorption spectrum consisting dark lines, which are formed when atoms gain energy, so the electrons pass from the higher to the lower energy. Which are formed when the atom gain energy. When atom gain energy. When atom gain energy. So I have a homework, and this is homework 4C. Briefly explain this thing. The first term. There are 3 types of sulfur emission of absorption spectrum. Is continuous absorption spectrum. And then band absorption spectrum. And also C. Explain about line absorption spectrum. Okay? So if you do that, and even just this issue of differences, you know the difference, you can use different phenomena and different approach in order to address the term. So this is the end of session 4C. Which I've been teaching about the spectra or in chemistry. I thank God who have been with me during the preparation of this session, and even when I've been teaching you, I thank God who have given me the opportunity to be with me. I invite you in the session 4D, when I'll be teaching you about hydrogen spectrum, and I also invite you in session 4E, when I'll be teaching about the quantum theory. And hence will be the end of this topic of hydrogen spectrum. I'm praying for you. May God bless you abundantly so that you remain safe and receive my invitations, and let us meet in the next session. Remember that to subscribe.